Invisible Doogie, and I'm here with a tutorial, a long-form tutorial for everyone on the basics of Project Spark. Now, if you're looking for a tutorial on different executions in Project Spark, for instance, how do I make a character respawn, or how do I make everything reset when I reset the level, or how do I make an inventory system, stuff like that, the best place to go is definitely by far Mescad. He has over 120 videos. He is amazing at his tutorials. But really, what I want to focus on is doing a more long form tutorial. Yes, this is going to be a bit longer. But think of this tutorial as sort of if there was a college course on Project Spark, this would be lesson number one. This would be the concepts, and specifically the concepts on code. Code with a K, that's what they call it in Project Spark, because code should be thought of as a programming language in Project Spark. And I'm going to jump into that very soon to show you and really start from the very beginning on code to break down the basics. A few other things are I will not be going through the biome tool, the paint tool, the sculpting tool, or props. If you want to learn any of that, if you're brand new to Project Spark, the first thing you should definitely start with is go into Project Spark itself and take that tutorial within the game. That will teach you all the different game mechanics, the different controls, and each of these different four tabs here. So this tutorial is for people who may not understand code and just want to get a basic understanding of code and kind of how it works. This is especially for non-coders or people who are new to coding in general or programming languages in general. This should hopefully help teach you about some general programming concepts, how they apply to code itself. So let me know in the comments section if you enjoy this, if I'm just too long-winded and say things that you don't really care about. If people are liking this, I'm going to start doing more long-form tutorials like this and sort of bring you through lesson plans where, one lesson plan I might delve into variables and how to do those, and another one I might go into vectors so let's get started. Let's go ahead and jump into this long-form tutorial. And so the first thing I've done is I have started an empty world. You can feel free to follow along with me if you have it up on your Xbox One, or if you have a dual-screen Windows computer and you're watching this YouTube video on one screen and have Project Spark open on the other, or you can just watch me and play around with it later. So this is a totally blank world that I've just started in Project Spark. This is how it looks like. It's just this vapid terrain with one character in the middle of it. So let's jump inside of him. Let's go into his brain. And his brain, this is how basically you can program things in Project Spark. So everybody already has a pre-built brain inside of them. Now, if you're new to code, some of this might make sense to you, like A pressed equal do jump. Okay, that makes sense. But it can be overwhelming if this is the first time you're looking at a programming language. So the first thing that I want to do is I don't want to go there. I want to delete this page. And I want to start completely from scratch. So here is a totally blank canvas brain. This brain is really the basis of everything in Project Spark. And it uses something, just a general programming syntax, when and do. Now, this is something that has been around since the 50s, the early 50s. It's taken other forms where it's been called things like if, else, when, for, and that's kind of been condensed down to these visualized tiles and visualizations of programming. So the general concept of when and do is when this happens, you do this thing. And what that is used for is it's used to tell the computer what to do, how to do it, and when to do it. You're basically creating an instruction manual for the computer or your Xbox, whatever's running Project Spark. This is the instruction manuals for this. In a completely blank brain, if this thing is left completely blank, this is an inanimate object that will do forever nothing. It has nothing inside of its brain. It has no programming languages. It's like a blank Word document, and it does absolutely nothing. As you start to add things to it, you start to give it instructions, and you're basically building artificial life and an artificial intelligence. People like to think of artificial intelligences as these really complex systems that are as smart as a 3-year-old and can have full conversations to you. But really, breaking it down, the very beginning ideas of artificial intelligence is creating something that can do things on its own and has some form of understanding on its own. And that's what you're really doing with code. You're just creating something through instruction manuals that has a semblance of understanding, whether it's just understanding that I need to walk forward just continually. That is still a form of intelligence where it's just understanding this is what I need to do. And again, you're doing it through these instructions. And so how code is broken down, how everything in a video game is broken down, is you have artificial intelligence, and you also then have player input. So artificial intelligence can also be thought of as automation, and that is basically something that operates on its own without user input. So for instance, I could just simply do move in direction forward. That is a form of automation. Now this guy is moving in direction forward, and he's going to continue to do that. Let's just quickly jump into test mode. And so he just continues to do that without any player input whatsoever. That is automation. Now, if I were to instead add a control input, so when I'm actually using the mouse and keyboard, so I'm going to do WASD, and I'm just going to move in direction forward, so WASD move. And now I'm using my keyboard to move this guy around. And so that is a form of player input. So all code can be broken down into automation and player input, things that happen on their own without your direct input. Sometimes it can be with your direct input, but they operate on their own without your influence, and things that are completely reliant on your influence inside the game itself. So with that concept, let's go into talking about when and do a bit more. So, I've talked about when and do already, and the basic concept is you're creating an instruction manual. And in order for that to operate, you have to give it certain parameters for how and when it should operate. So for instance, when I first started, I did do move in direction forward. Now that is a very basic form of automation where this guy will always move in direction forward. You can have, with code, you can have something that's only on the do side that doesn't need a when. And that's an important thing to note, is you don't always need to have, when you're coding something, you don't need something on both sides, both the when side and the do side. If you have an operation on the do side, what that means is this will perpetually always do this one thing. When is how you basically take that whatever thing it's doing, this guy's moving forward, he will just continue to. When is how you kind of clamp that down. You tell this guy that, well, you're only moving forward when this thing happens, or you're only moving forward for this amount of time, or it's basically constraining him so that he understands that, okay, I should only move forward when I detect the player. So how does that look? So let's do when detect player, move in direction forward. So if I were to put a player next to this guy, he'll continue to move forward until he doesn't detect me anymore. And the detect sensor is something that I won't get into how that operates yet, but the general idea is that now this move in direction forward that has a clamp on it, that has a indicator of when that should happen. So now we have given this character a very basic instruction of what to do, and then we've also now told him when to do it. And that's basically how when and do work. You got the do side, which is what do I do, and the when side is when do I do it. And that is how all code operates. So we're going to use this concept now to create a player from scratch. And so in order to do that, you have to think about what you want your player to do. So one of the very first things you want your player to do is to be able to move around in the world. So for that, let's start with the do side, which is move. So now this guy is just going to move, but he has no player input whatsoever. So he doesn't understand that that I want him to move in a certain way. So that also fits on the when side when you're telling this guy to move through player input itself. And for here, you want to go into controls. Basically, anytime there's a control input, that's a player input. And since I'm on keyboard, I want to choose WASD. And so now you've given the move a parameter within the player itself, where now it's saying that when I am pressing WA, S, or D, then I'm moving. Now, Project Spark takes a shortcut here, and you would think that if you had to manually do things, you would have to do when A is pressed, you move backwards. When S is pressed, you move forwards. When A is pressed, you move left. And when D is pressed, you move right. That is, that's kind of a way to basically manually do his movements. So, for instance, W would be move in direction. Backwards. And then you do the same thing for these. But Project Spark does a shortcut where you don't need to manually do all this. And what it basically says is you're using the WASD commands, and Project Spark will just automatically assume and understand when you're pressing W, you go back. When you're pressing S, you go forward. When you're pressing A, you go left. When you're pressing D, you go right. And so the great thing about code is it can condense things down into a way and make shortcuts for you, so you don't have to do certain things. So now we have the startings of a player. We now have input on the when side, and we have what that input equals on the do side. So the next thing you want to do is a very important thing is look at the camera of the player, because you can't have a player without a camera following them. And so here is where we actually don't need player input. So on the do side, I'm going to go to the second page, go to camera, I'm going to do a follow camera, which is basically third-person action-adventure standard follow camera. Now for this, I don't need anything on the when side. So why don't I need anything on the when side? Because I don't want a constraint on this camera. I don't want to tell this camera that you should only be a camera when I'm moving, or you should only be, basically I should only have a camera on me when I'm doing a certain thing, because you should always have a camera on you. If you're the player, then you always want to have a camera on you. So this is an example of when you don't need something on the when side. This is an example of when you need player input on the when side. Now let's do something where you have automation, even though we're creating a player. So let's, for instance, let's just make it so every few seconds he jumps. So we're going to do jump. So now if I don't do anything, let's just show you. He's just going to continue to jump, right? Because we haven't given any sort of modifier to when he's going to start or stop jumping. So let's change that and just say we're going to give this a countdown timer, which basically says I'm going to count down to how many seconds. How many seconds am I going to count down to? Well, let's have you count down to 2 seconds. So, okay, I'm counting down to 2 seconds. After 2 seconds, I'm just going to jump, right? I'm just going to continue to jump over and over again after 2 seconds. So that's what that looks like. And it's been 2 seconds, and now he just keeps on jumping. So, well, that's not useful. So instead, let's say, all right, after I count down to 2 seconds, I want to jump, but I want to reset that. So let's loop it. And the general idea of a loop is this is another concept of programming, another general concept that has been around for a while, where when you are looping something, what it does is, we'll use this for an example of code actually goes sequentially through everything. So how the code starts is it starts with, okay, countdown timer. How many seconds am I counting? 2. Okay, cool. Oh, I'm looping this. Okay, back to countdown timer. All right, how many seconds am I counting? 2. All right. Oh, I'm looping this again. Countdown timer, 2, and so on. It just keeps on looping it over and over again. Because you're telling it, a loop is basically saying, go back to the beginning. And then it goes through the beginning. It gets all the way back to the loop, and the loop says, all right, go back to the beginning again. And it just keeps on telling you again and again and again until you tell it to stop looping. This is what we call an infinite loop. And an infinite loop is going to continue to loop throughout time and eternity, basically until you stop playing the game. If we were to keep this game running for 20 days, then it would continue to loop. So I got every 2 seconds now I'm jumping, and just continues to loop over and over and over again. So looping is another general concept of code itself. The next general concept, which is an important general concept, is child lines and parent lines. So with child lines and parent lines, these are basically indentations of lines. So for instance, we're going to use this line number 3. We're going to create another line, and we're going to say, I'm going to attack. Now, if I indent this line just like so, this is now a child line under this parent line. And what that means is this child line, whatever is on the win side, that affects the child line as well. Whatever's on the do side that doesn't matter for the child line. But a child line looks at its parent's line for what's on the win side. So it's sort of like this guy is an offspring of this parent line, and it biologically has imbued in it everything that's on the win side of the parent down here. And now I can add another modifier to this child line. So let me think of a good modifier to add here. Maybe it is when I am detecting an enemy. So now what it's doing is saying every 2 seconds I jump. There's a child line now. So it looks at that. And by the way, this looping that happens here, it's only affecting this line right here. So just because this line loops doesn't mean this line loops. Looping is just contained to the one line. But now this child line says, okay, so every 2 seconds, if I'm detecting the enemy, I'm going to attack. It's not attacking the enemy, it's just attacking in general. That's an important other concept, is I haven't set that what I'm actually attacking here. So now if I go in here, then I'm going to be jumping every 2 seconds. But I'm not attacking. And that's because I'm not detecting an enemy. So let's go ahead and just add an enemy right here. Let me just quickly remove everything from this enemy except what his team equals, because what the team equals, that's what defines who's an enemy of who. And let's get him really close to make sure that I'm actually detecting him. And he's still not attacking the enemy. So let's quickly see. Let's see his attack sensor. So, I have a countdown timer of 2 seconds that I'm looping, and I'm looking to detect an enemy. So you'd think, okay, this guy has a team set of 2, so he should be my enemy. So, why am I not attacking? And the reason for that is because you don't know what enemy you are yet. So let's go ahead and just quickly add on what my team is equal to. And so now this makes this enemy's tiles active, or effectively work. And so now I'm jumping, and I'm attacking. Of course, I'm not telling it who to attack or what to attack. And this is purely a form of automation. So now let's bring the detect sensor back down. Now let's go into the next important concept. So what we've done, just to quickly review, is we created a child line that waits for every 2 seconds, and then if it detects an enemy, it attacks. So the next important concept is else. You have basically 3 main indicators within code. You have when, you have do, and you have something that's hiding right here in the timing and logic style only when it's a child line. This only appears when something is a child line. So let me just repeat that again. If this is a child line, this appears. If it's not a child line, then you see this red indicator come up that, hey, this thing doesn't work anymore, because what else is it's a command that's saying, it's a command that's looking at the when side of things. And if this when side of things is not being fulfilled, then it's saying, okay, that isn't fulfilled, so here's what to do. So it's basically saying, instead of this, do this. So, for instance, I've now made else a child of this detect enemies. So the important thing is else needs to be a child of whatever you are making it the opposite of in order to work. So I have when detect enemies, do attack. So if I have else here, what that's saying is basically, if I'm not detecting my enemies, so else is giving the exact opposite of what's here. If I don't detect my enemies, then instead I am going to shoot. So just like that, now it's running through, and it's basically saying if the opposite of what's happening on the parent line is happening, that's what else is, then it does something else instead of there. So this is very useful and very important when you want, for instance, when you get into really a lot more complicated things like ray casting, and if something is not 20 meters away, or if the distance of something is shorter or longer than what you need it to be, then having the else tile means basically that when that thing isn't fulfilled, it's going to do something else. So let's jump back in here. I'm just going to increase this guy's detect sensor. And the goblin is in his detect sensor. I'm showing you what his detect sensor looks like. So let's make it a tiny bit smaller. Okay, so let's go into test mode. So he's attacking. Now he's outside. He's outside of his detect sensor. So now I'm jumping and I'm shooting. Now if I move back, I'm back to attacking. And as soon as I get out of its detect sensor again, I start shooting. So just like that, I've given myself conditions now of when something should operate, when it shouldn't operate. So that is, that's kind of, those are all the basic building blocks of how code can be constructed. Now, I'm not going to use this tutorial to walk you through the actual meaning of each code tile, because that would take hours and hours. That's something that hopefully, if you guys do enjoy this, that I'm going to go through more of and more of again. But the next thing I want to show you, which is a very important part of brains, is the idea of pages. So every brain can have a multitude of pages. Just like they can have a bunch of different lines of code, you can have a bunch of different pages. And if you go up here to the very top, you'll see it on just a blank canvas that we started with. It'll show one of two. So if I click next, I go to a brand new page. And so now for some people this might be confusing, because you have a brain here, right? And you've given all these instructions. So what is this second page used for? What would be the use of it? So this is where you can go pretty complex inside of a character, and you can make them do certain things in certain states, basically, and then certain things in other states. And that's how this page could be useful. So for instance, if I want to do, I'm just going to change this to, instead of once, page entered. So when I've gone into this page, my team equals 1. Now on this page, I'm going to do when page entered, then my team is going to be equal to team 2. So let's go ahead and let's just copy all of this text that I've put here. Well, not text, all these code tiles I've put here onto the second page. Okay. Now, one other thing you might have noticed is as soon as I added something onto this page, it shows now 2 of 3 pages. So whenever you start adding stuff to a page in Project Spark, just like as soon as you add something to a new code tile or a new code line in Project Spark, it automatically adds the next one. And that's just simply so that you can continue to add more and more, and you don't have to go through any crazy steps to add another page or another line of code. So if I were to add just one simple line on this page, like move, I now have 3 out of 4 pages. 3 out of 4 pages. So let's go ahead, and on page 1, we'll do when I press the spacebar. And I'm going to go ahead and do a switch page. Now again, I'm not using this time to walk you through these lines of code. I'm, again, just going through the concepts. But what I'm basically just adding here is a way to switch between the 2 pages. And I want to switch to previous page. Okay, so now I have a way to actually switch between these 2 pages in the world. So here's what I've done. I've made a page 1 and a page 2 that are the exact same in every way, except for one of them has that I'm on team 1 and one of them has that I'm on team 2. So what do you think will happen when I do that? So, just like before, I'm punching. And now, I'm detecting him, right? I'm right next to this guy, and I'm shooting. So let's press spacebar again to jump between the next pages. And now I'm punching again, because I'm detecting him, and I'm punching. And we'll switch to page 2 by pressing spacebar. And I'm detecting him, but I'm shooting him. And that's happening because I'm now on the same team as this guy when I'm on page 2. I was on team 1 when I was on page 1, and I'm on team 2 when I'm on page 2. And if we look at this goblin, then I had set him to team number 2. So on page number 2, he's still detecting the goblin, right? I was right next to the goblin, but the goblin is no longer my enemy. So I'm no longer attacking. I'm just going right to else, shoot. Because, again, this else line of shoot will only work and will only operate when this is not being fulfilled. So detect enemies is no longer being fulfilled, even when I'm right next to this goblin, because he's now my ally. And so just like that, then I've changed, basically, the core concept of this guy's mechanics and this guy's code. So this is a very base way of explaining how page switches can be used. But really, inside of a character, you can kind of change the way that they operate by switching from one page to another. And so just to further illustrate that, the only difference between page 1 and page 2 is that it goes from team 1 to team 2. So could we do that here on page number 1? And the answer is yes, we could. It would take a bit more time, a bit more coding, but yeah, you can technically, I mean, anything you do by switching from one page to another, you can technically take care of on just one page. It's usually harder, and it's might be a bit easier to understand and to follow along with. But you don't need to really switch pages. There's always a workaround to doing things on one page. But that workaround uses something called values or variables. In Project Spark, they call it values, but we also call it variables. And these values or variables, the concept is you set what they're equal to, and then you can use that to change states, just like a page switch changes guy's state. Because with a page, as soon as I'm on page number 2, it's whatever's on page number 1 doesn't matter. It's like that doesn't exist anymore. But whatever is, when I switch back to page 1, it's like whatever's on page 2 doesn't exist anymore. But it doesn't mean that these are two separate objects. Because, for instance, on page number 2, if I remove this, WASD, and remove follow camera, so if I switch from page 1 to page 2, then on page 1 I'm saying that when WASD are pressed, I do move, and then I'm having a follow camera. So these two aren't being set on page 2. So what happens? So again, I'm on page 1, and I'm shooting, and I can move with WASD, right? Just like this. I have my follow camera. So I'm going to press spacebar right now. Now, so I've pressed it, and now there's two things that you'll notice. I still have this follow camera going on. This follow camera is working, but I'm pressing WASD, and I'm not moving at all. So let's press spacebar again, and now I can move with WASD. I still have the follow camera. I press it again, and I still have the follow camera, but I cannot move. This is to show you that certain things can carry over from one page to the next. User input, player input cannot transfer over because there's something being set on the win side of things, being constrained. But a follow camera can be brought over because, first off, on this page, there's nothing overriding that follow camera. If I had another camera, it would override it. And second off, there's no constraint on this camera of when it should stop working. So this camera is just going to continue to move onto page number 2. And so, like I said, I could do everything that I've done in this page switch by using something called values or variables. But this is another lesson on its own. The number of values and variables, Boolean variables, objects, object sets, text, vectors, colors, so on. I've actually created a tutorial that walks individually through each one of those. It doesn't give the concepts that much, but it walks through them. But that's a whole other time onto itself. So hopefully that gives you some of the core just building blocks and core understanding of how Brain and how Kode works in Project Spark. If you did like this, again, let me know. And I do plan for lesson number 2 to go into values and variables and give you the concepts of those and how Booleans and everything else works. So just let me know in the comment section if you did enjoy this, you did like it. And hopefully we can all learn the concept of code and programming better together.